Today we're going to learn about something called differentiation of implicit functions. Now, what do you mean by implicit function? So, function in which we cannot write y exclusively as a function of x. So, let's say if we we used to write y as a function of x. So, when we are able to write like this, like y on the one side of the equation and all the x terms on the other side of the equation, we say this as explicit function. But what if we cannot write like this? What we have a mixture of x and y on both sides, and we cannot separate it. Okay. So, for example, if I write y equals to sine of xy. Now, this is the way of writing in which we have y on the left also, y on the right also, and we cannot actually separate all y together on one side and put all x together on the other side. So, it's very difficult to uh, put in the above format. So, that's why it is called implicit function. So, you can understand that implicit functions are those functions in which we cannot write something like y equals to fx. So, here y cannot be expressed only as a function of x. Okay. So that's why this is called implicit function. Okay. So how to differentiate, how to find dy by dx in such case? Let's say I am interested in finding the dy by dx, given that y equals to sine of xy. So let's say I want to calculate the left hand side dy by dx, and this is given to you. So what we write is, and how we start is. So there are two methods. So first I will discuss the chain rule method. So using chain rule, what we can write is differentiate both sides with respect to x. Differentiating both sides with respect to x. So how we write is, you can write dy dx of y and d by dx of sine xy. This is how we should write first. Okay. So d by dx of y equals to d by dx of sine xy. Now the LHS is something we were looking for, so that's our job is done. So this is dy by dx, and I'm interested in finding the dy by dx, so I'll just leave this as such. On the right hand side, there is a mismatch of the variable. So we know how to use the chain rule. We can put xy here. Now this will match, right? And then we need to multiply with d of xy, because that is what we have brought from our side. And so we can write like this. Now this is exactly the chain rule that we learned in the last class. So dy by dx is equals to, this is the chain rule which says this will become cos of xy. But this itself is like a product rule. So we can write this as x outside and the differentiation of the second term, plus y outside and the differentiation of the first term. And now what is interesting here, that we have all dy by dx term. So what we have dy by dx on both sides of the equation. So what we'll do is we'll rearrange to bring on the one side. So dy by dx, if I take common one, minus x cos xy equals to y cos xy. So dy dx equals to y cos, and this is our answer.
So
So
what
what
did
did
you
you
do?
do? Yes, sir. In the second last step.
In the second last step,
Yes, sir. What did you do, comma?
see this is the common. If you multiply this term with both terms, so x cos x is one term. So if you brought everything on the left side, so you will get dy dx common. This is same here. 1 minus x cos xy. 1 minus x cos xy. If that is not clear, rewrite again. Just you try to expand the bracket and bring all dy dx on the LHS. So dy by dx is already here. Just multiply both in x cos into dy by dx plus y cos. So now we have dy dx on both sides. So bring it on the left. You should convert it like this. Now, is it fine? Is it okay, guys? Tell me, please. Does it make sense to you now? How I have taken the common?
So then in the second step, why did you add them both?
Hello, sir.
Okay, this step.
Yeah, sir.
Okay, okay. So I think you have forgot the
Sir,
chain.
is it the product?
Yeah, this is the product rule. This is the product rule. So we have multiplication of two terms. So what we do differentiation? How we do the differentiation? We take one outside, differentiate the other. We take the other out, differentiate the first. We add them together, right?
Yeah, sir.
That's why we have added together. And d by dx of x is 1. So that's why y into 1 is 1, y only. And we cannot do with anything with the dy or dx. So we can leave this as such. Okay. Is it fine? Okay.
Yes, sir.
Okay. So I think Harshit was disconnected. Are you there, Harshit?
I'm connected, but so by another device, so that's why.
Yeah. So now you can see. Okay. I hope. Okay. If you have doubt, then I will continue with the.
So I have a doubt
Yeah. Just mute the other one, because if you speak with two device with both mic on, it will create some very bad nuisance. So just switch off the mic of one and then speak from one.
Yes, sir.
Yeah.
Hello, sir. Sir,
Yes,
the
I can.
implicit and implicit function, please will you just give a short?
Yeah. So implicit function means a function in which you cannot express y exclusively as a function of x. Okay. Like you cannot write y equals to only something which is made of x. So the other function, when I write y equals to f of x, is called explicit function. So I started with an example. So if you write y equals to sine of xy, then we have y on the left hand side and y on the right hand side, and so we cannot separate it. The y is such a mix with the sine angle that we cannot take it out and take a common. So y will remain the way it is, and you cannot segregate actually. And therefore, such functions we say implicit function. So to deal with the differentiation of implicit function, which is, let's say, given, you differentiate both sides with respect to x, apply the relevant formula of chain rule or whatever rule you know of differentiation, you will get multiple terms of dy by dx. So simply bring all terms of dy by dx on one side, take common, and then write the answer like this. So Our answer will be finally dy by dx equals to y cos xy upon 1 minus x cos x1. Okay. Next.
Okay, sir.
So let's do some more problem. Let's see if I give you y square equals to ln xy. Now, does it look implicit or is it explicit?
Sir, impressive.
No, no, is it implicit or explicit?
Sir,
Yes,
implicit.
sir, implicit.
Implicit. So let's see, we can write this as ln x plus ln y. So I can bring all x one side and all y other side. But here, what we can understand or see that we cannot write y equals to fx. So we have y at two places, right? So of course it's the implicit function, and how to differentiate it? So you will like differentiating both sides with respect to x. So do it and tell me the answer of dy dx.
Sir, I have a doubt that, sir, why cannot we equate it like ln y plus ln y square is nothing but ln y cube, no? So cancel
Yeah,
the
yeah,
ln.
actually. So here ln x plus, sorry, my bad. I have made a mistake here. So what I have written is ln x plus justice. I have made a mistake here. So y square minus ln y is ln x. Okay. So now you can't write. Actually, I have written wrongly. This minus this equals to this, right? So can we write now? Okay, that expression was wrong actually. My bad. So now here we have y square minus ln y equals to ln x. And now we cannot put y as a function of x again. So this is your essentially an implicit function. So you have to differentiate. So what we'll do? Differentiate both sides with respect to x. And apply the chain rule if you need it, and else solve it. Tell me the answer.
Sir, answer is 2y square minus 1 equals x upon y
2y
upon x.
y dash minus 1 by y dash is 1 by x. This is the answer. If
Sir,
you
no.
differentiate,
Answer is 2y square minus 1 upon y is equal to 1 upon x.
very good. So I
Hello,
think
sir.
this is your answer. Yeah.
Sir, why cannot we take y? We can take the square in the right hand side and
Mm-hmm.
Sir,
we
yes,
can
that was my
root
doubt.
ln
I
x y.
was going to ask that thing. That can we take a root of ln
Uh-huh.
xy?
Yeah,
Sir, to
yeah.
simplify that formula.
No, if you write y equals to root of this, how it will help? Because again, x and y is here, no? Or what you can write is, or you can write is, you can directly use from here directly. You can solve from here directly. You could have written 2y y dash 1 by xy into xy dash plus y. Now it's difficult to understand what I have written.
No, sir. It is.
Okay, it's fine, very good. So if you multiply inside, what you get is y dash upon y plus 1 by x.
So y dash is dy by dx, right?
Yeah, yeah, that's a short way of writing. So 2y minus 1 by y into y dash is 1 by x. So 2y square minus 1 into y dash upon y equals to 1 by x. And therefore, you can add 2y square minus 1. Y dash is y upon x. So y dash is y upon x into 3y square. So you can choose the way you want. It's not a difficult thing. Okay.
Sir, I have a sir. Please, will you solve from the red mark step? Y square minus ln y is equal to ln x.
All right. So let's say do it one again. Y square minus ln y equals to ln x. Okay. So first I will differentiate to y square. Y square you cannot differentiate with x. You have to use the chain rule. So you will add d by dy of y square multiplied by dy by dx. Right. I have written the two steps at once. If we have not understood this part, so you first add the differentiation with respect to x. So how we usually go about, we write d by dx, okay, minus d by dx, d by dx, and just make some more animated thing. So here we have y square, here we have ln y, and here we have ln x. So on the RHS, it's completely okay because it's the same function, and we know the differentiation of ln x with respect to x, and the answer is 1 by x, right? I hope this is okay with you. The
Yes.
RHS. Now look at the second term on the LHS, the term close to the equal sign. So it's a d by dx of ln y. You can't differentiate y with x. You have to use the chain rule. So you will add d by dy of ln y. That's okay into dy by dx. Similarly, you cannot differentiate y square with x. You have to write dy square by dy multiplied by dy by dx. Now the things are perfectly okay. This is 2y. This I prefer as y dash minus. This is 1 by y. This is y dash. This is 1 by x. So you take y dash common, so you get 2y minus 1 by y. And we have done this so many times. Y dash is y upon x multiplied by 2y square minus 1. Is that clear now?
Yes, sir.
Okay, of course you need a practice, so we'll do some more practice here. So solve this question. You start with
Sir, I
something
just
on.
have a simple,
Mhm,
sir, I have just a simple doubt. Sir,
mhm.
ln xy, we can write it as ln x plus ln y.
Yeah, right.
Yeah, right? Sir, no, because I didn't know. That's right.
Okay, so that's a property of log, no? I think logarithm is done in math class. Have you learned the basic logarithm?
Yes, sir.
Yeah, so that
Sir,
you
Yes,
I
can use
have
sir.
done, but I didn't know this form. This form.
okay, no problem. So it's a property that when you have a product of something, let's say x, y, z, w, so you can write as sum of all everything.
No, sir. Sir, he taught us this.
Yeah,
Yeah, so
this
this
is
is like the basics.
yes, this is we also learned class maybe in high school also. So anyway, so coming back to the some other, I mean, like let's work with some more value, I mean, functions. So, okay, this is the function which is of my interest. X square y plus x y plus sine of x y plus maybe e power x square y. That's like something very weird. Okay, equals to 10x, something, anything like that. I could have written 0 also. Okay, so this is the something like a very bad function. Who will do this? Anyone interested?
Yes,
Sir,
sir.
we can directly apply divided by dx and then shift the sides.
Yeah, so you can
Yeah,
apply
you
dy
can.
dx on both sides, and you have to use the somewhere product rule, somewhere chain rule, somewhere both, and this is
Even
really
product
lengthy.
rule, sir.
Yeah, even product. So what I'll do one thing to make it simple. Okay, let me remove one term. Now this is okay. Uh, relatively easy, right? So try this question, or you want somewhat more easier question? So
No,
those
sir,
who
it's
do are,
okay.
it's okay.
No, sir. It is okay, sir.
Okay, go ahead, go ahead.
So that is 10x
Yeah, it is 10x.
Sir, I got the answer,
Okay, so tell me the answer.
but I don't know if it's correct, but I'll tell. So the
Yes.
answer is y,
Why?
then bracket 2x plus 1 plus, no sir, the bracket continues,
Okay. Okay.
plus cos xy, then bracket close, minus 10 is equal to minus x y dash, then bracket open, x plus 1 plus cos xy.
Okay.
Yeah.
Okay. So that looks quite a good job done, but let me just verify it. Whether it's exactly what we are looking for. So we can. Okay. The first term is pretty easy. It's okay. Anyway, so let's differentiate this. We can write as okay, I'm writing directly 2x into y plus x square y dash plus xy dash plus y plus cos xy into xy dash plus y is 10. So we have minus here, we have minus, and we have minus inside here. All right, so 2xy plus y plus y cos xy. Yeah, this looks pretty close. Right. And then we have x square plus x plus x cos xy all into uh, y dash is 10. Yeah, so we have x plus x square plus x cos x. So I'm taking this term first. All into y dash equals to 10 minus, and take y common, which is 2x plus 1 plus cos of x y. Yeah, so I think this is what you have got the right answer. Y dash is 10 minus. You can just change the sign by putting minus on the other side. So that's one side is perfectly okay. Okay. And the x y dash, yeah, that's fine, correct, because you if you take x inside, okay. So your answer is absolutely correct, very good. So you can take x comma in fact, so you will get 1 plus
So
x.
we have to put just y dash on one side.
Yeah, y dash on one side and everything else on the other side, so that
Okay,
is
so
your dy by dx, right? This is what we're looking for.
yeah.
So we have this answer, so your answer is absolutely correct, very good job done. Okay. So now, because this is a like, if I keep on increasing the difficulty, this way of the solving question becomes more difficult. So I will introduce you to a newer concept called concept of partial derivative. Concept of partial derivative. Now, what a implicit function suggests, what it suggests is like if we have implicit function in which x and y are like complexly related, so we can think of the entire equation as a three-dimensional graph, which means we can make the xy as a variable and we'll introduce a new function called z, which depends on both. Then it looks like, so z is one variable which depends on the two other variables called x and y. So to begin with, how to use the concept of partial derivative, we have some notation for the same. So the d by dx, like when you write dy by dx, it is called exact differentiation. Exact differentiation. So we have something called del y by del x. The how we read is del y by del x, and this is called partial differentiation or partial derivative. Now, because del y by del x is called partial derivative, okay. Therefore, the meaning goes like this. If I write del y by del x, it means the x is the differentiator. So it will only take x as variable, and if other variable will come into picture, it will behave or treat such variable as just like a constant. So when you differentiate partially with x, then y is taken as constant, not as a variable. Similarly, if you differentiate with respect to maybe y, not y, this is we should write as. So let's say if you differentiate some function z with y, then it will take only y as variable and x will be taken as constant. So here y is variable and every other parameters
That in the numerator.
z z.
So in the second one also, why dz by dx? I mean del z by del x.
Yeah, okay, I will tell you, just wait. So this is called the multivariable function. What is multivariable function? Normally, you have habit of writing y equals to x. So this is called one variable function. Okay. Let's take we have a rectangle of length x and width y. So how we can write area? It is x into y. Okay. So area is x into y. So if I take area as z, so you can see this z is xy. So the area is a one variable function or multi-variable function. Area is
Multivariate.
multi-variable function. So should we differentiate with x or should we differentiate with y? Let's say I want to differentiate area. The answer is you have to differentiate either with x or y partially at one time. It means at one you will take one as variable and other as constant. So when I write del a by del x, it means for me x is variable and the term x and y, which is like a product, you're not supposed to use the chain rule, product rule, because here y is a constant. You're supposed to take y outside and you just differentiate. See, the answer is only y. Easy. And if I write del a by del y, what does it mean? What is constant here? X is like a constant multiplier. Take it out, and this is easy. You can see that the area is varying with respect to x, and the rate of variation of area with x is y, and vice versa. So the rate of variation of area with y is x. So this is the example of partial derivative, and in physics, we come across various situations in which we come across a multivariable function, and whenever we have a multivariable function, so to differentiate, we use the concept of partial derivative instead of exact differentiation. Now, what I'm going to do is I'm going to solve the all questions which you have solved so far with the help of this new concept called partial derivative, and we'll see the power of it.
So only we have to only remove the derivative only one
Yeah,
related
yeah. Yes,
variable,
yes,
no?
yes. We have to take one variable as a variable at once and all other as constant. So when you differentiate with respect to x, except x, everything is constant. When you differentiate with respect to y, except y, everything is constant. Is this okay?
Sir, if there is x, y, z, so if we differentiate with respect to x, then answer will come y, z, no?
Yeah, right, right, correct. So we'll see some problem, don't worry. So this is a very basic concept. Now, okay, look at back the first question we solved. Like, what is the first question we solved today? Y equals to sine xy, right? So we'll start from there. So y equals to sine xy. Okay. So y equals to sine xy. So yeah, I want to differentiate this, but here we have implicit function. So the rule is first I need to make it as a multivariable function. And how we make it? So you say first you bring everything on the one side and you put to 0. So I make everything on the one side and make other side as 0. And then everything on the left side, we name it as z. This is how we start. So this is the first step. You create a new function called z, which depends on x as well as y. So now you can say z is a multivariable function and it depends on y as well as x, right? So we can say z is a function of x comma y. Is this clear? Okay, guys. Okay. Now the rule says to find the dy by dx, there is a simple rule. Put minus sign, write del z by del x upon del z by del y. This is the answer. So is it difficult or easy? You remember?
How can you explain again?
So first of all, you have a given equation. This is the question you want to solve. Step one is bring everything on one side. Either you take a y on the right or a sine of xy on the left. Do either of them. Okay. Once you bring everything on the left side, name it as z, like this. Now z becomes the multivariable function of x and y. Okay. So the dy over dx, to find dy over dx, we use this formula, which is a negative of del z by del x upon del z by del y.
That is a formula.
Yeah, that is the formula. So this is what you need to remember.
So
Okay.
we can write it also as del z by del x into del y by del z.
No, no, we have to differentiate the z. Na? So we have to write del z by del x and del z by del y. If you write del y by del z, then how will you differentiate? Okay. So we can differentiate this and we can differentiate this. We'll see this. Wait. So let's begin with this question. So del z by del x. Y is a constant, so it will become 0 minus sine of xy. Y is a constant. Okay, so we have to use the chain rule. So first we get cos of xy into, and if you differentiate with x, y is a constant, so we'll get just y.
Sir, it will be x.
No, you're differentiating with x, x, y. So y is constant, we'll take it out. We have only differentiation of x. It's okay now.
So what happened to that formula?
The formula. This is the first part. You got the del z by del x, right?
Oh yeah, we have to still find del z by del y.
Correct. So now go ahead and find del y, del z, del y. Tell me the answer.
So minus 1 minus cos xy minus x.
Just
Sorry, cos
one
xy into x.
into x. Yeah, right. But this time the y is variable, so x is constant. That's correct. So it's good to write like 1 minus x cos xy, right?
Yes, sir.
Now dy by dx is how much? Minus. The first term was minus y cos xy, and the second term is 1 minus x cos xy. So it's become minus 1 plus y cos of xy. And what is the answer in the beginning? See, the answer is same. Check.
Sir, this formula works for all type of
Yeah,
functions.
all. It's not a formula. It's a perfect proof actually. So proof, I mean, is not required here. So this is what we need to remember, that dy by dx is equals to negative of, first you differentiate with x and then you differentiate with y partially by behaving or taking other as constant, and then just take the ratio. Now this you can apply to any question which you have solved previously, and you can verify it. So let's do this question and check whether you're getting the answer in an easier way. Try this question again with this concept of partial derivative.
So we have to solve this question with the new method.
Yeah, so that you can verify it, right? The idea is that you use the method and see for yourself whether you can whether this can be used or not. So that will give you some added confidence. That's it. Okay.
So, so while
Yes.
finding the del z by dy, there
Mhm.
is one more dy by dx coming in the.
No, 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 no. It will never come. When you're differentiating with y, so every x is constant. So just behave that is like a number, and you can take it out of the integration.
So, but if the situation is like 10x by sorry, d 10x by dy, then
d 10x by dy.
yes, sir.
It's 0. Like when you're differentiating x with y is a variable, x is a constant. So when you differentiate the constant, what will you get? 0.
So in that case also we have to consider x as constant.
Yes. Yeah. See, you're differentiating with y, na? If you're writing del by del y of 10x, then it's entirely a number which will give you 0 answer. Is this okay?
Yes, sir.
Okay, go ahead now.
So can you once show how you did it in the previous question?
Okay.
So I got the answer, the same as you got in that.
Okay, that's very good. So you okay now this is how we did the first question. You can just see for yourself how it has been done and then try to go back to the question. The first step is bring everything on the one side and make it and call it z or z, whatever you would say. And then you differentiate with x, assuming every y is constant, a number. Repeat the same process with y, and then take the ratio as per the formula. So you have to try this because this is very very important.
Please will you show the previous slide because I want to check my answer.
Just
So when we take dz by dx, no, del z by del x, that time we have to do the everything same only, like product rule, and that all will be same, right?
yeah, everything same. Just the thing is, you have to treat the other variable as constant. That's it.
So can you show the previous slide that where you solved it for the sine xy with this method?
Yeah, it may take some time, but that's okay. So you guys can practice till you actually grab this beautiful concept. Okay.
So I understood the concept, but sir,
Okay.
since
I'll
I'm
solve
able to solve the question which you gave, that big question in normal
Okay.
derivation.
Don't worry. So don't worry. I'll give you some more question and we'll practice it. So let's say you just say tell me a question. Like you guys can choose the first term. First term will be chosen by okay, Harshit, you tell me the first term. Any random value of x and y.
Cube root of x.
cube root of x. Okay, fine. Second term, tell me, Atharva.
Log of x or log of 5.
Log of x. Okay, and Atharv.
X only.
See, you guys are not giving me implicit function. I was looking for implicit. You gave me explicit.
Sir, तो cos of xy.
So फिर से करते हैं. Let's play this game again. First term, cos of xy. Second term, Atharva, tell me second term.
Root of xy.
Root of xy. Very good. And Atharv, you tell me the third term.
Sir, I told the first term. Harshit has
Okay.
to.
Harshit, tell me the third term.
So x y the whole cube.
Like this.
Sir, the whole cube.
A whole cube. Like this.
So it will be cube, no? So it will
I
be.
cube. Okay, I thought cube. Okay. Fine.
Yes, yes, sir.
Okay. Equals to, tell me some number. Let's say, okay, I'll put it from my side. Maybe 5xy. Yeah, that's okay. So now we have one big term. So I'll write my z equals to the first term cos xy. This is 1 by 2. This is x cube y cube. This is minus 5xy. Because we have brought everything on the left side and we have called it as z. So we have terms like x and y, x and y, x and y. So first we differentiate with x only. So y will be my constant. First is cos of some number into x, right? Y is a number. Cos of number into x is sine of minus sine of this, and the number we multiply outside by chain rule, of course. So we'll get is y, because y is constant. We'll take it out, and del by del x of x is 1. If I'm not understood the first part, then first and then I'll do it in more detailed way. So you can
Oh, sir, understood.
Okay, very good. Okay, the next part is again the root of y is a constant. I can take it out just like this, and then we have a differentiation of root of x. That's simple question. We have y cube constant. We have to differentiate. Thus, just x cube. That's simple. And we have 5 y constant. So we'll just differentiate x. So it's just very pretty easy, right? No need to go for the complex method. So it's a sine of x whole into just y. This y will take out and x will be 1. This is very famous differentiation. We have done this before. 1 by 2 root x. This is y cube into 3x square. Okay, we are done. Now try to understand this part, and then if you have really understood this part, go for the next part, which is del z by del y.
I got disconnected from when you were solving del of x upon del of x.
Yeah. So you just see through, just go through and try to realize. Take some time, but not an issue.
Sir, I got the answer.
Yeah. So what is the part of del z by del y?
It's minus of x,
Minus of
x
start with x, y, x, yeah.
bracket. Yes, that will be sine xy
Yeah,
plus
that's
root of x upon 2 root y
yeah,
plus x cube into 3y square
yeah,
minus 5x.
yeah, that's correct. Absolutely. I think there is no issue because
So,
yeah,
sir, I have a doubt that
yes.
when we take del z by del y, sir, we take no, sir, we take minus at the last when we take del.
We take minus as last. Yes, correct. So now the thing which we have to do is minus of this upon this is dy by dx. So now imagine if we try to do this sum by the previous method using the chain rule and the all the rules, it would be really lengthy to write first of all because it's many terms. But the partial differentiation method makes this pretty easy, at least in terms of writing. And you can do one at a time, get the answer, leave it, and then do the other part and then solve it.
Sir, here we take minus from both common and then like that.
Yeah, you can just take the ratio, take a minus common, what you want to take common. But in the formula, you have to put an extra minus sign apart from their own sign. Okay. So we have to put minus
Yes.
del z by del x upon del z by del y. This is something you have to do. Okay. Okay. Okay.
Sir, I just have a doubt that if sine xy is equal to y, we can shift y on right hand side or sine of x on right hand side. And sir, anything is valid, no?
Pardon. Once again.
Sir, if there is sine of xy is equal
Y-
to y,
Yeah, you can shift to either side. Yeah, you can shift on the other side. Doesn't matter. It doesn't matter.
okay.
Okay, I will tell you something very interesting. Why this happens? Why we get this answer? Uh, when you write some equation, let's say y minus sine of x, and I say z. So if you remember, this was zero, no? When we had the actual equation, this is zero. So actually, you are assuming this as zero, right? So that's why I'm writing z equals to this. Let's say if I write something like this, okay, just you say like this. I'll tell you something why this happened, why the formula comes. Y minus sine of xy. Then I'm saying 5, some constant, just number. So anyway, when you differentiate a number, it becomes 0. So if I say this as z, so y is my just constant. It should not be a function. And now, how we differentiate it? Okay, how to differentiate something like this? So d of z, there is a way of writing. So let's write it like this. Then d of z by like this. Okay, not like this. This is not a function. So z is a function of x comma y. So the rate of change of z is written as, there is a formula for this. Differentiate this, uh, differentiate this with respect to x multiply by dx plus differentiate this with y multiply by dy. Okay, and this is the formula, actual formula, which is from the advanced mathematics. So if z is a function of two variable x and y, then the change in z we write like this: partially differentiate the function with x multiply by the actual value of change, then do it partially, then change. This is how we write it. But since z is constant, so the dz is always zero. So this will always imply zero. and therefore, if I write this equation equals to 0, so what will get? And if you rearrange
So what are we doing here?
the formula, how to derive the formula?
Derivation.
Yeah, the derivation of the formula itself. Okay. So you
Okay.
just see it and you can leave it. I'm just showing you how it exactly, I mean, it comes into picture. So then we write, if you rearrange the terms here and here, you'll get the answer which we were saying. So del by del x of f of xy upon del by del f. And that's why we write this as minus del by del x of z, because this is how we started with. Anyway, no need to go beyond this. Like this is something, uh, just leave it. So this is how the formula is derived. Anyway, so this is something very advanced computation. Okay, no need to worry about the same. You just remember the formula and go through it. In just in case when you will learn lots of mathematics, maybe at the end of class 12th, maybe in the BTech first year, you will understand what I have written here. So till that time, just wait. Maybe we'll face something like this more in uh, class 12th physics. So maybe by that time you will have the idea how to do it. Okay. So don't worry at all. Even if you're not getting it anything, it's perfectly okay. So next, we'll end this implicit function here only, and we'll go to something called now, because we know differentiation. So where we can apply in the real world, something is called application of derivative. So the concept of derivative is applied almost everywhere, uh, be it something called optimization problem. So the most useful thing is the optimization problem, and we use as a rate measurer, like we if we are interested in finding the instantaneous changes. So like the stock market, right? If you have heard about the stock market, so the software, okay, which works on works for the stock market, is actually used with the help of is made with the help of calculus. So because the changes are very fast, very quick, and we need small changes, like in what happens in less than 1 second. Okay. So because we are looking for the change in very small interval of time, because that's very crucial in determining the price of a stock, and even the price of the stock will change many times within 1 second. So the changes are very quick, and we use the method of calculus or the derivative to design the software of the trade. So when it comes to the manufacturing of some product, the size of the packet, how much and what dimension we must use to use the least amount of material to create that packet. So again, that uses the concept of the calculus. Okay. And in various design, okay, in statistics we use calculus. Calculus is used everywhere, and there are various types of modeling which also requires a concept of calculus. So the two major things that we are going to see here is called the optimization problem and the rate measure or the instantaneous changes. Now you will never hear these words in the math class because the optimization problem is called maxima and minima. And then we have a rate measure. So that's why we say to use the derivative as a rate measure, we can use the um, concept of calculus. So first of all, we'll learn something called the maxima and minima. Okay. So what is maxima and minima in context of calculus? Although at our level, we learn this concept only for one variable, but as you move in advanced, courses of mathematics, maybe if you're doing PhD in mathematics, so you can actually do the maximum and minima with maybe a set of variables, maybe 10 variables or 20 variables. But when it becomes too large in terms of variable, we don't use this uh, manually doing it. So we use some kind of software, and in software we use the optimization. We have many theory for the same. So those are very advanced levels. So the entire world is the industrial goods are designed with the help of optimization theory, and it uses the concept of calculus. But that's very advanced. So what we are learning is the one small piece of that big picture, and our discussion will be restricted to only one variable to solve any question. So let's begin with. Okay, so first of all, maxima and minima. We are going to learn maxima and minima. So let's plot something. So let's say we have some graph y equals to fx. It may represent y may represent the maybe the height of a person. X is the demographic region. I'm setting all countries on a one line. So let's say if I put all countries in one line, and if I plot the average height of every country, so what do you think? Will we get a straight line or a line which will change its height?
The
What do you
line
think?
which will change its height.
Correct. So if I plot average height of every country, and let's say I am putting every country on a straight line as a variable, and its average height on the y-axis, so we may expect something very interesting. Not much, but a slight variation. Maybe oh, we are reaching the maybe Nepal. Okay, the Americans, Europeans. Okay, giant. Okay. So the idea is, if you will get something like a graph like this. Okay, assuming its graph is continuous and not, let's say there are very large number of countries, and we have something very weird shape. But if you look at the shape of the graph, which represents some sort of function, then you can see that it will have some trough, it will have some crest. Okay, so all the crest will happen at some point, and we don't have just one crest, we have many crests locally. You can see that we have one crest here, then we have one crest here, one crest here, here, okay, here. So we have many crests. Now what is so good about all these crests? If I ask you one small question, that what will be the slope at every peak or every trough? Slope means if you draw a tangent at those points, what we are going to see or you're going to
Zero.
observe. Pardon?
So it will be parallel to x-axis.
Exactly, you got it right. Absolutely correct. So anyone else who has observed or realized that this fact that every tangent drawn at all these crest and trough are parallel to the x-axis? How many of you have realized this fact?
Yes, sir.
Anyone who is not getting it?
Yeah, so it's parallel.
Yeah. Now that this is the first observation we understand. Like when we have a graph, graph means a smooth graph, which is not uh, changing its slope rapidly. We talk about those graphs in which the slope is changing smoothly, called the seamless graph. Now, how to identify the graph which is seamless? You will not get any corners. If we have a graph with corners, such graphs are called like a rapidly changing graph. It's not a seamless graph. If I draw something like this, imagine if I draw like this. Now, these vertex are rapid changes because the slope on the left and slope on the right will change drastically. Because if I take the first peak here, the slope on the left is following this line, but just next to this point, the slope is following this line. So, in the neighborhood of this point P, in the neighborhood of this point P, we have two strikingly different slope, and therefore it's called the rapid change. And such changes are not, studied under the concept of maxima and minima. So, what kind of graph we are going to study here is the graph in which the changes are seamless, smooth. Are you getting the point? So in our chapter, in this chapter of maxima and minima, we are only interested in curves which are seamless, without any corners and without any break. So without any break means it must be continuous, and without any corner means it must be differentiable. Now, what is the meaning of differentiable? A differentiable means you should be able to determine the slope uniquely. So a function is said to be differentiable if at every point, you can determine its slope uniquely. Now the problem at point P is, can we determine the slope uniquely? Can we draw just one tangent at point P? Okay, I will tell you something interesting.
No, sir.
If we have a seesaw with one corner, so the line of the this is like a line, like a tangent to the seesaw. So how many lines we can draw passing or touching this point? So we can do infinite points, infinite lines like this,
Yes, sir.
and all of this line will pass through just point P. So can we define the unique tangent? The answer is no. We cannot define the unique tangent. So the simple answer is, if we have a corner in the graph, it means you cannot define the unique tangent, and such points are called non-differentiable points. So in theory of calculus, we apply the concept of maxima and minima only for graphs which are continuous and differentiable. So I'll use the word differentiable means that someone is able to draw tangent at every point of the graph uniquely. Okay, that's the meaning of differentiable. So I will mention this. We learn the concept of maxima and minima for graph which are continuous. It means you should not have a break in the given interval. You should not have a, you know cut from, like, it's the graph is here then like this. So this is like a break. So we will
Sir,
not appreciate. Yeah,
sir, if the line is straight,
yeah, that is also continuous, and that is also differentiable because there is no sudden change.
sir, if the line is parallel to x-axis,
Yeah, that's okay. That's a zero slope. So you will have no maxima, no minima. That's fine. But that's at least it's continuous and differentiable. Because if a line is straight, then there is no apparent change. There is no quick changes, right? Slope is 0 everywhere, right? 0, 0, 0. If we draw tangent, all will coincide with each other, right?
Yes, sir.
So every slope will have, every tangent will have a 0 slope in such case if you are talking about parallel to the x-axis. So that is also defined, that is also continuous, that is also differentiable. The rule is, if you can think of a differentiable function, you can think of a maxima and minima. If you know that a function is non-differentiable at a particular point, you cannot find the maxima or minima. So the rule for maxima and minima is the function must be continuous, that is without any break, and it must be differentiable, that is without any corners. So that's a very simple way of saying it. Not going too much into mathematics, what is differentiability and what is this and that. It's a complete chapter in itself called differentiability, and again that we will learn as a part of mathematics in detail. So till that point, I'll tell you some simple trick to understand, and that's called a function is differentiable if there are no corners. So corner in a graph means it's not differentiable. Why? Because you cannot define a unique tangent at that point. And geometrically, we know that dy by dx represents slope of the tangent. So because the geometrical meaning is with us, we know the meaning of dy by dx geometrically. So we must understand that we cannot define that way. Anyway, so the corner concept is not applicable for this concept. Now we are not looking for a maximum minimum is the absolute maximum or the absolute minimum. Here in physics, the maxima minima, uh, or even in mathematics, I'm saying the maximum minima is only pertaining to the local points. They're called local maxima and local minima. So what we're going to learn is called not a maxima minima, it's called local maxima and minima. What is the local? Like, are you richer than your neighbors? You're locally rich. And are you poorer than your neighbors? You're locally poor. That's the only definition. Now, what does it mean? I'll give you some examples.
Comparison with local.
Yeah, your neighbors. So don't compare with who is the richest person of let's say, okay, that's okay. The richest person of Mumbai is Ambani, right? Unfortunately, he's the richest person of India. Unfortunately. So Ambani is the richest person of, let's say, Mumbai. Then is he the richest person of the world? No.
No, sir.
He is the third, fourth now, but he's not the richest person. So I can say that he is locally the richest person, but not globally. Similarly, if I ask who is the, like, where you live, Harshit, where you stay?
Virar.
So if I ask that who is the richest person of Virar, then he need not to be the richest person of entire the western suburb. Like, the thing is, someone who is the richest or poorest in his locality is called the local maxima or local minima. So if I draw a graph like this, so this is a very interesting graph, and I will just point some values. So this is the point of the local maxima at the first location. This is the locality. This is a, let's say, how rich you are, the money you have. This is the corresponding money you have here. This point is x2. This point is x3. This point is x4. This is x5. Now tell me, guys. Okay, at x4, yeah. So minima is at which location? So can you see the location at which we have the minima, local minima? Can you see the trough in the graph?
X2.
and
X4.
yeah, right. X2 and X4 are the local minima because that's a locally. If you are at that point of the graph, you can see both of its neighbor, the right neighbor and the left neighbor, are above him. So in mathematics, the right neighbor is called the right hand limit, and the left neighbor is called the left hand limit. It means you are taking two values which are very close to the point. They are point which is really close, but not that point. So if you are less than both of your neighbors, you are the point of local minimum, and if you are more than both of your neighbors, you are the point of local maximum. Now look at the point here. If you look at the neighbor of this dot, the right neighbor is rich and the left neighbor is poor. So it's the point of neither maxima nor minima. I hope this is clear.
Yes, sir.
So now what is the feature? Like what is the common thing about all points of maximum? What is common among all?
All have same slope.
Correct. All will have same. So that's the most striking feature that they have. That if you draw a tangent at these points, no matter whether it's locally maxima or locally minima, all will be parallel to the x-axis, or we can say that all will have zero slope. So when we have a equation of a graph, let's say this is like some sort of equation, y equals to f of x, because I am taking the one variable function. And if I find the slope of the graph, so what we do is dy by dx. Okay, so dy by dx is the slope. And if I equate this to 0, what you get is you get an equation. And the solution of this equation, one, what it will give you?
It's
If
a
you
Coiny
solve,
constant.
you'll give the you will get the roots of this equation will give you x1, x2, x3, x4, x5. Because you are equating slope to 0. So at how many points you will have zero slope? 1, 2, 3, 4, 5. Okay.
Yes, sir.
So we can say that the dy by dx equals to 0. So roots of equation dy by dx equals to 0 gives the possible points at which we may have either local maxima or local minima. We are not interested in the maximum of among all. We are interested in the maximum in the locality. Now you can see a very interesting fact. Who is more richer, x1 or x4?
X4.
X4.
But you can see the x4 is the poorest person in his locality.
Yes.
But he is still richer than the richest person of at x1. Okay, and that is
So the
the
locality you're talking matlab between the limits, no?
yeah. It means at x4 the point will be the local minima, but in terms of value, in terms of the y is the value of that point. So in terms of the y value, it is still more than the maxima of x1, right? Isn't it?
Yeah.
Yes, sir.
So the idea is when you are the minima of a point, it does not mean you are the minimum in a value. You are minima with respect to only your neighbors. Okay. So when you are at the bottom of a locality, you are called minima, but your value still may have more than the x1. So the maxima minima only refers to the locality, not absolute maximum or absolute minimum. It just talks about that are you richer than your neighbors? You are maxima. Are you poorer than your neighbors? You are minima. If you are richer from one neighbor and poorer from the other neighbor, you are nothing. You're just a common man. Okay. So we are interested in a graph. Uh, so let's say I will tell you something. Okay. If I write a complex equation y equals to x cube plus root x minus 1, just some random equation. So what I'll do is just give me one moment. I will start my GeoGebra. Just a moment. So GeoGebra. Have you guys gone to the GeoGebra to do something, to draw some graph and all?
Yes, sir. So it is a site on your
Yeah.
Google, no?
Yes, yes, yes. It's site on Google, geogebra.org. It's very interesting. You should, make yourself aware of these sites because future is all about these things. So as you move forward in your learning, this will help knowing these sites. All right. Okay. So look at this. What was the equation? X cube, right? Can you
X
guys tell
cube
me
x minus
plus
1
x minus 1, right?
plus root x minus 1.
Plus x minus 1. Just a minute, okay. X. Or maybe maybe minus x. This is not making it possible. Mm, uh, now some better function I have to use. Plus, plus. Okay, this is not a good equation. I need to change the equation. I'll just write this simple question. X square minus 3x minus 4. Okay, fine. So I just use the now I can use this is better. Okay, so finally I got the better question. So let's say I'll just share it. Can you guys see this screen now? Can you
Yes,
guys
sir.
see this? Yeah. So on this screen, on the left hand side, we have the equation which I have taken x cube minus 3x minus 4. Okay. And because this is the equation, a cubic equation, you can see this is the graph of the equation. If this graph is not visible, I'll just make it larger. Can you see this equation now? And you can see something very interesting that it graph will have two, points of local maxima and minima. So the minus one, can you see the minus one? X equals to minus one. It's here. It's here actually. Somewhere. You may see the pointer.
Yeah.
So at minus one, there is a tangent. If you draw a tangent, what will you get? You'll get a zero slope, right? So this
Yes,
is the
sir.
local. This is the local maxima, and you can see the minima, which is at one, exactly below one. There is a maxima. So this is a minima, local minima. Can you see that? It's
Yes,
here.
sir.
So for every equation, 1 and minus 1 is called the roots. So 1 and minus 1 is like a x1, x2, x3, x4. So for this equation, we have two roots. Can you see the roots? So the roots, okay, this is the equation. Now, if you differentiate this function, what will you get? Tell me. Differentiate. Guys,
So
come on.
3x square minus, so
Yeah.
3x square minus then
Complete it. What is
minus
different?
3.
That's
So
it.
3x square minus 3.
Correct. Now equate to 0. Equate to 0.
Minus
So what are
3.
the, so if you equate to 0, what will you get? X equals to?
Minus 3.
No.
No. Equate to 0 before differentiation or after
So
differentiation?
1.
After differentiation.
So
After
1
differentiation.
and minus 1. So 1 and minus 1.
Correct. You are getting the x square minus 1 equals to 0. So x can be either plus 1 or minus 1, right?
Sir, I didn't understand.
You differentiate first. I would differentiate it, yes or no?
Yeah, sir, 3x square minus 3.
Right. So that's again when you differentiate a function, you get another equation.
Yeah.
Now equate to 0.
So, sir, we have to solve it. Then x will be
Yeah.
plus or.
Yeah. So what does it mean? When you equate to 0, it means you're trying to find
Make.
the location at which the slope is 0.
Yeah.
And you got 2 points, 1 and minus 1. Your answer is 1 and minus 1, right?
Yeah, sir.
What does it mean is the answer 1 and minus 1 is saying that at 1 and at minus 1, the slope is 0.
Okay, sir.
I hope you have understood. If not, let me know.
Sir, yes,
So,
sir.
at minus 1 and plus 1 slope will be 0.
No, minus 1 and plus 1 is the x coordinate at which on the graph you will have 0 slope.
Yeah.
And that is what the graph is showing also.
Sir,
Can you see
can
the
you
graph?
give
Now? That is what the graph is.
Sir, you an equation
Okay.
and
Just,
you will
just,
calculate
just,
the number of, I
just,
mean, where, and
just.
then you
Wait.
impute in this.
Pardon for this. Just a minute. Yeah. Look at this. I'm doing something. Okay. So look at this. This point is minus 1. If you look carefully, and this point is plus 1. And if you look at the point here, this is the plus 1. This is the minus 1. Can you see that? So what you got mathematically, when you differentiate this function f dash x, you got 3x square minus 3. So if I write 3x square minus 3 equals to 0, what does it mean physically? It means I'm trying to find the location or the roots of the equation, which gives me 0 slope, because you are equating to 0. It means the slope is 0, so you get the answer plus minus 1. So which is simply
Then,
saying that at x equals to 1 and minus 1, the slope will be 0, and which is absolutely correct.
sir, if we put except 0, so we will get the slope. So we will get the x values for that slope. No?
When you equate to 0, it means you're getting the slope 0. If you
So no,
equate to
I am
1,
saying that equation we will get a slope that number.
once again, your voice is breaking. Once again,
Sir, if
tell me.
we equate equal to any number, so sir, if we equate to any number, so we will get the values of x for that slope. No?
Values of x for that slope. Yeah, correct. So let's say if someone is saying that, sir, I want to know at what point the angle is 45 degree. It means the 3x 3 is tan of 45. Tan 45 is how much? 1. So 3x square minus, or equals to 4. So x square equals to 4 by 3. So x equals to plus minus 2 by root 3. It means if you know at which point we have 45-degree, so the x value will be plus or minus 2 by root 3, which is roughly how much? 2 by root 3 is how much? Just check. 2 by root 3. Just divide. 2 by. It's 1.15. 1.154, right? Okay. So
Yeah, sir.
1.154 is very close to 1. So what I'll do is I'll just take just a moment. Just, yeah. So maybe this is working now. So I'll take a tool called a line.
Hello, sir. Sir, I got
Yes.
disconnected. So please you explain the X, this one, this part, left hand side.
Okay. The other part which I was writing is just a moment. Yeah. So let me do this tool. Okay. So here I was writing here something equation. All right. Yeah. So this is the expression which I had written, and in this expression, the first expression was like this. Like if I equate the slope to 0, it means I'm trying to find the values of x at which the slope is 0. But let's say you're trying to say that at which point the slope is 1, like 1045-degree. So then in that case, you will equate that to 1, and then the answer will give you those points at which slope is 1. So slope is 1 at one point, we got 154, which is very close to somewhere here, maybe somewhere here. And if you draw a tangent there, maybe I can choose my own line. So this line will be having 5 degree. So this point is 1.15. Like this. So when you differentiate a function and equate to 0, what does it mean? What does it mean when you differentiate a function and equate to 0?
Sir, it gives the uh, slopes of that one.
Then when you equate to 0, it means
It will give
your,
the
yeah,
slope for 0 for it.
it will give you the points of 0 slope. Understood?
Sir, can you give
When
one more
you
sound?
just wait. When you differentiate a function and you equate to 0, you will get the points of 0 slope. Like all the points on the graph at which slope is 0. That's the meaning of differentiating and equating to 0. If this point is not clear, I'll not move ahead.
Yes, sir. Clear it. It is clear. Sir, is the मतलब अगर if dy by dx अगर if our dy by dx or derivative is 0, then the means that it is indicating that the slope is of the it is of the crest.
Correct, correct, correct. Crest or trough, both.
Yes, sir.
Anybody else who has still some doubt?
Sir, the value would be plus and minus 1.154. No? So there will be slope on that minus 1.154. So, no?
So at 1.154, slope is 40, slope is 1 actually.
So no, minus 1.14.
Yeah, again, there also slope is, if you draw at -1, because the value is somewhere here, it's like somewhere here. And if you draw a tangent there, again, it's 45 degree. You can see that. So if you plot at -1.154 on the left of left of -1, if you draw a tangent, you get again 45 degrees. So you can see that at these points, the slope on the graph is exactly 45 degrees.
Sir, so both these slopes are parallel to each other. No?
Yeah, correct. Both slopes are parallel to each other. Right. Like if you want to find any slope, if you want to know the point on the graph at which we have that slope or not, just equate with the value of slope and then check the value if x is some real number. So it means you have that point, that slope is possible. If not, it's not possible. Okay, so I'll give some more example. Don't worry. So let's go back to our like whiteboard. So coming back to our whiteboard.
Sir, if f of x is equal to x,
Yeah.
then sir
F
in
of
the
x equals to
x.
f of x equals to x, like this.
Yes, sir.
Okay, yeah.
Then in I had typed my input in the GeoGebra calculator suite, and in that I got the straight line passing from 0. But sir, x can be any integer, no?
Yeah, so this is the graph of y equals to x, right? So this graph will pass through the origin. That's absolutely correct. Like this. So where is the problem? So if x equals to 0, y equals to 0, so this is the point. If x is 1, y is also 1, so 1 and 1. This is the point. If x is 2, y is also 2.
Yeah, sir. Understood.
And if you differentiate this, what will you get? 1.
So yeah, 1045 degree. Yes, sir. 1.
This is 45
Because
degrees.
it is 90 degrees, so both side it will be 45 degree and then.
No, nothing like that. 90 degrees. So if you
No, but it
differentiate,
is
it will be
passing
1.
from the middle, no? So
Yeah. So yes. Okay, fine. So that's correct. Okay. So now the idea is that when you equate dy by dx to 0, you get all set of points at which the derivative, sorry, the graph will have 0 slope. So that is called the equation to get the critical points x1, x2, x3, x4, x5. In terms of mathematics, is called critical points. The points at which there is a chance of getting either a maxima or a minima. We are not sure that which one you will get, the trough you will get or the crest. We don't know about the two, but at least one of the two is going to be there. That's for sure. So solution of dy by dx equals to 0 gives critical points, that is at which points at which what will happen, at which we'll get either maxima or minima. That's simple. Okay. But if I want to know the point of maxima separately and minima separately, then what we can do, or what we should do?
Sir, what is given to us?
Let's say you have a graph given to you. So you have a graph, and you want to mathematically identify the location at which we have only we want to know the maxima, not the minima part. We want to know the maxima. That's it. That's the idea. Okay, so for that there's a method actually that we need to understand. So what is the method? That's so that's called the second derivative test. Second derivative. Let's say if you do not have the graph to see it by yourself, if you have just a mathematical equation, you differentiated and you equated to 0, you got two answers, -1 +1, but you're not sure which point will be corresponding to the local maximum and which point will correspond to the local minima. You have no idea. Although the GeoGebra is giving you the graph to see it, so that's very easy for us to understand. Okay, that yeah, that's maximum, that's minima. But what if that GeoGebra is not present to you, you do not know about the shape of the graph, then how will you determine the maxima and minima? That's the question. What will you do? So we use the second derivative test. What is that second derivative test? It's very easy. Look at the point of minima. First, we'll start with minima. So I will just do only one minima, not many, and we just want to understand the nature. So I'm drawing a graph like this. Okay. Okay, this is fine. In this graph, can you see minima? Hello, hello, guys. Am I audible?
Yes, sir.
Yes, sir. We can see.
Yes, sir.
Yeah, we can see minima, right? And we don't have anything else actually. We have just one minima. Okay, so we have minima at this point x. Okay, can you draw a tangent here? Yeah, of course you can draw a
Yes,
tangent.
sir.
So the tangent at this point will be parallel to the x-axis, right, guys? So slope is 0, so tangent is parallel to x-axis, isn't it?
Yes, sir.
Now what we do is we will draw one more tangent by moving ahead of x1. So try to move next to x. So if you draw a tangent just next to x, what we can see? Is slope positive now or negative? Not from 0 to infinity. You go from the point of 0 slope to the
No, sir.
next
I
point.
was telling that the slope will move from value 0 to infinity, which is
Yeah. Correct. That's absolutely correct. So what you can see, as you move ahead, so what we do is in mathematics, we say like this. So mathematically, at x we have 0 slope, but at x plus dx, slope is positive. So the slope at 0, slope at, okay, I like darker side. So slope at x plus dx is more than slope at x. So it's increasing slope, right? Slope is guys increasing, isn't it? Hello, hello, hello. Slope is increasing, isn't it? Yes or no?
Yes, sir.
So dx is just the
Yeah,
what?
very close, very close. The neighborhood, the neighbor of x. The right neighbor of x is having greater slope than x. The right neighbor of x is having greater slope than slope at x. That's it. See, if you are a minima, then both of your neighbor will have more slope than you in terms of value, right? Hello, hello, hello. This is confusing. Okay, the slope at x is 0. Now the slope next to x is what?
Positive.
Positive slope. So from 0 to positive means it's increasing or decreasing?
Increasing.
Exactly. This is what I'm trying to say here. As you move right to of x, the slope will grow. Okay. But look at the other graph, like this. Can you see
So
them?
it
Can you see
means
them?
x plus delta x, no?
Yeah, x plus delta x is the next point. What is the problem with this? I don't know. Why it is disturbing you, x plus delta x?
No, sir. I was just asked.
One is the x point, other is the point close to x on the right hand side, and we call it x plus delta x. Okay.
Sir, earlier when you wrote dx, I thought you were saying the differentiation of x. That's why.
No, no, no. This is just value. We are adding extra value dx.
Yeah, so now I understand.
Yeah. Now look at the other graph on the right hand side. If you look at the graph on the right hand side, you can see at the topmost point, that is the maxima, local maxima. The slope is how much?
0.
0. But imagine the point very next to that point. So let's say,
Which side?
so if we have, if I draw a tangent here, now draw a tangent very next to this, you will get something like this.
So which side?
And it's an obtuse angle, so the slope is negative. So numerically, the first slope is 0, but the next slope is negative. Because the slope is pointing down, so it's negative slope. So as you go next to the point of maxima, what do you expect? Your slope will decrease or increase?
Decrease.
Will decrease numerically. Okay, so the slope will decrease. It will become negative. So that is the property by which we differentiate between the maxima, the local maxima, and the local minima. So at local minima, the slope will grow. At local maxima, the slope will decrease. Yeah, minus infinity. So eventually
Sir,
it will
it
become
means
infinity
if
only. It's not minus, it's just infinity.
sir, it means if x plus delta x is positive, then the next will be maximum. If x plus delta x is negative, then the next one will be the minimum.
Correct. Absolutely correct. Absolutely correct. That is what we mean actually. So how to put this into mathematics? Because this is like common sense. But the idea is that can we put this into some mathematical framework which can help us in determining the same? So there is a simple way to do it, and I will show you some very interesting proof. So we can say that slope for minima, I mean, of course, local minima. So by default, it's local. So for minima, slope at x plus dx must be more than slope at x, right? Guys, come on, tell me yes or no.
Yes.
Now what I'll do is I'll write like this, slope x plus dx minus slope x is positive. Right or wrong? Tell me. Is this correct?
Yes.
Okay. Keep on saying yes or no. So now what I'll do is I'll write slope at x plus dx minus slope at x upon dx, because dx is positive, is also positive. Yes or no? Is this okay?
So what did you do now in third
Arre,
step? How this
I
step?
differentiated with dx. I'll divide by dx.
Oh, okay. Okay.
I divide by, not different, divided by dx. Is okay now? Okay.
Ah, yes.
Now, if y equals to fx is the way of writing, so the dy by dx we write as f dash x, right? This is how we write symbolically. So if I substitute the value, I can write f dash x plus dx minus f dash x upon dx is positive. Okay. So I will, what I'll do is I'll make it a better way. So what I'll do is I'll make a change, small change here. I'll add first delta x, some extra big value. Don't worry, this is not a big thing. So I have taken 2 points, one is x and one is x plus delta x, that way the way we did before. Now I will take a limit. Limit delta x tends to 0 f dash x plus delta x minus f dash x upon delta x is positive. Now what this is representing? This is something very famous. We have done this before.
Yes, sir. You gave it a starting.
So earlier we had fx, now we have f dash x. So when we have fx, we got the differentiation called f dash x. So when we use the same formula with f dash, what we get is called the f double dash x. So this is called f double dash x is equals to limit delta x tends to 0 f dash x plus delta x minus f dash x upon delta x. This is nothing but the second derivative of x called d2y by dx square. It means you differentiate first and then again you differentiate. So when you differentiate 2 times, it's called second derivative. And how we write it? So we write it as d2, it's like this. How to read this? d2 upon dx square of y. So this is your operator. This is the second derivative operator which you operate on y, and this is same as d by dx of dy by dx, the way you want to learn. Or this is written as double dash x, or this is written as limit delta x tends to 0 f dash x plus delta x. और अगर ये कुछ समझ नहीं आता है तो बस इतना याद रखो कि for minima the f double dash, not like this. For minima, just remember that the d2y upon dx square is positive. That's it. So if you are at the point of minima, the second derivative must give you a positive answer at that location. That's it. And similarly, I will not write again the same thing. Similarly, for maxima, that is the local maxima, by default I said. So for maxima, you write the second derivative test must give you a negative answer. So what if the second derivative turns out to be 0? Yeah, that's also possible.
Then it's
So, sir,
would
again
be a
the
straight line.
zero only, and
Yeah,
it will be crest.
correct. Pardon. Once again.
Sir, it will be
Then it
crest.
would be a
Oh, wow, okay. Just wait. I think. Waliki, okay. Who is saying? One at a time. Harshit,
sir,
Athar.
if d2 y upon dx square is equal to 0, then it would be a straight line. No?
Correct. That's true. So for a straight line, this happens, and it is also called the point of twist. Now, what is the point of twist? I'll show you. What is the point of twist? Okay, so just a moment. That's very interesting thing actually. The second derivative, if is equals to 0, this is called point of inflection. Now, what is the point of inflection? It is the point at which the slope will go from positive to negative. It means it's like this. Imagine a graph like this. Just let me do one example of that. Okay. So imagine a graph is okay. First, I'll do like this. Now, what I'll do is I will keep the right part as such, but I will just twist the left part. If I twist the left part, it will come like this. right? Can you see the graph? So it is like I have twisted the left side below the x-axis, and now I have the complete graph like this. In such graph, what you cannot realize that there is a tangent existing here, which is parallel to x-axis here like this. So the part near the origin is a flat part, which you can't see. So the slope is zero again. Here at origin, the slope is zero, which you cannot actually feel it. It's very non-intuitive. But there is a tangent existing at that point. And this line is not cutting the graph. It's not cutting the graph because the graph is becoming parallel for some time, which you can't see and feel. Then it's taking the other side. So when we have a curve or transforming its slope from the like positive to like it's changing the direction of slope. So it's changing the concave to convex, convex to concave. We say concavity or convexity. So the earlier graph was this graph was concave up, but now you can see this is the concave up, and now it is suddenly concave down. So when we have a graph in which we have the concave and convex, so the point at which the concavity turns into convexity or vice versa is called point of inflection in mathematics. And every point of inflection will have well-defined slope, but you cannot see. Slope is there. Okay. Okay. Nation. I'll I'll do this.
Sir, if the this same type of concave convex type of graph is there, but it is above x-axis, this type of and is above x-axis, and then we can see the slope, no?
Yeah, we can see. Then exactly. That is what I'm trying to say. Because it's on the x-axis, so it's not visible to you, but it is there. Look at this. I was exactly coming to the same point. That's very nice of you that you understood and pointed this. So now, can you see this graph now? It's very interesting. We have tangent, well-defined tangent here. Oh, sorry. We have well-defined tangent here actually. But this tangent is difficult to feel. This is actually tangent point. Because when we go from the convex to concave, you have to be flat for that duration. So you cannot go from concave to convex without becoming flat. Is it possible? It is like, can you turn back without stopping? थोड़ा मुश्किल है, I know it's non-intuitive. तो अभी याद क्या रखना हमें कि जब भी कोई ग्राफ, कोई कर्व अगर कॉन्वेक्स से कॉन्केव या कॉन्वेक्स से कॉन्केव से कॉन्वेक्स, जिस पॉइंट पे वो ऐसा प्रोसेस होता है उसको कहते हैं पॉइंट ऑफ इन्फ्लेक्शन. उस पॉइंट का सेकंड डेरिवेटिव जीरो होता है. ठीक है, थोड़ा सा नॉन इंट्यूटिव है बट इसको एक्सेप्ट कर लो फिलहाल के लिए. और जब ये क्लिक होगा फ्यूचर में कभी तो अच्छी बात है. So this is how we make the test of second derivative. I'll continue with some more points, but the time is running out. So
Upon dx2 is nothing.
Can you solve one equation from the
yeah,
double
correct,
uh,
correct.
RT?
Just a minute. I'm solving it. So let's do some problem. At least we should do one problem for today before moving to the next concept. So just a minute. You can give us a very good question. Yeah. Yes. Yes, I got it. Yes, I have the problem now. This is not. Yeah, this should. some difficult problem so that you can explain this concept. Okay, so the problem is like this. Question: fx equals to x cube plus ax square plus bx plus c. So determine the constants a and b in order that the function may have a relative maximum. Okay, okay. So your question is like this. Okay, I'll share the question. It's a big question. I like it. Find the constant a and b in order that the function fx equals to x cube plus ax square plus bx plus c may have the first part, a relative maximum. What is the meaning of relative? The local, the
Local.
relative maximum. So this is from the American textbook. So that's why they use the word relative. It's the world best book of calculus, and it's called the Thomas calculus. And a relative minimum at x equals to 3, and b, a relative minimum at x equals to 4, and a point of inflection at x equals to 1. Okay, so there are too many words here. So first you read the question. I'll solve. Don't worry. Just read the question. At least read twice, thrice to first understand what I'm trying to, what this question is trying to ask.
Sir, I have calculated the derivative. Now I have to
Also,
put the x value.
One by one. Just say one by one so that the echo should not come. Yeah, tell me.
Sir, I have calculated the derivative. Now for the first question, I have to put x value as 1 minus 1 in that
No,
derivative.
no. First of all, the local maximum is at -1 and the local minimum is at 3. The first case. So if you differentiate and equate to 0, the root of the equation should be -1 and 3. Okay. The root of the equation should be -1 and 3. Correct. It is saying that
Yes, sir.
assume the maximum at -1 and the minimum at 3. So it means if you differentiate and equate to 0, and if you solve for the roots, you must get -1 and 3 as the answer, the roots. Okay. So how we solve question like that? So what we do is we use the concept of sum of
Sir,
the.
first we, sir, can we try this for?
Yeah.
Can we
Try
try?
this. Yes, please go ahead. Go ahead.
Sir, the A and B
Yes.
conditions for A and B means for A, it is
You
like that.
have to do something to find A and B. That's it.
Okay, sir.
Now, what you have to do is up to you. I will not tell you.
Sir, for first one, answer is A is equal to -1 and B is equal to -3.
The first one, the slope will be 0 at -1 and 3. That's the only part. Okay, you are saying the answer.
Yes, sir. So my A answer is -1 and B answer is -3. For A and B,
Okay.
in second one, in B sub
No,
question.
no. See, listen. The A and B together will solve the question. You cannot have answer for A and B separately.
Yes, sir.
The
I have
A will
the
be
first one A is equal to -1 and B is equal to -3, and I'm solving for question number 2 like that.
no. That's why you got it wrong. The first A and B are the conditions which will determine A and B. A and B are the conditions using which you have to find A and B. Both are for the A and B only. Like you cannot get the two pair of answers. The answer is only a unique answer. A and B will have only one value. And A and B are the conditions that we are supposed to use it to arrive at the answer of A and B. Okay, I'll tell you how. Just wait. So look at this. How to begin this question? This
Sir,
is
I
not a-
got it.
Yeah,
Sir,
tell your
only
answer.
1 minute. I'm just calculating the last one.
Okay, fine. Go ahead. This is very interesting problem. Very interesting. I won't say difficult or easy, but it will open the mindset how to attempt question like this. It's not easy one. So you're solving from the world best book of calculus. So someone who is very much interested in mathematics and loves solving questions, you can always buy and keep this book forever. It will help you in future. It's called Thomas Calculus. Bit expensive. I think on Amazon it's available. Even you can keep at home as a like souvenirs. Very interesting. It's not expensive. It's easy. 781 rupees. Thomas Calculus, 14th edition. The old edition is better actually. Thomas Calculus, the Pine edition. Not Pine, PNIA, old edition. The actual book price is 15,000. The original one. Yeah, that's nice.
Sir, I got A value 6 and B value -15.
So just keep the answer. We're ready with you. I'll just solve and we'll check together. Okay. Okay, guys. So let me do this question now. The first part says that A says that you may get a maxima at -1 and minima at 3. So I can say -1 and 3 must be roots of equation f dash x equals to 0. So let's differentiate this. What is f dash x? 3x squared
Sir,
plus 2x plus b, right? And
yes.
if I equal to 0, I should get the answer as -1 and 3. So what I'll do, we know the sum of the root formula. Sum of the root is how much? It's quadratic. So in a quadratic equation, the sum of the root is minus b by a.
Yes, sir.
Alpha plus beta is minus b, which is 2a, by a, which is 3. And what is the alpha into beta? It's c by a. Okay.
Yes.
Now what is given is that minus 1 and 3 are the roots. Minus 1 and 3 are the roots of the equation. Okay. So the product of the root will be how much? Minus 3. So the minus 3 equals to b by 3. So we got b equals to, yeah, 9. Okay. And alpha plus beta will be 2. Is minus 2a by 3. So 8 turns out to be minus 3. Just a minute, something is wrong. Okay.
Sir, how did you get b by 3 as minus 3?
Okay. I'm
Sir,
searching it.
what I did was,
Yeah, yeah, tell me.
sir, I did first I got the same derivative that 3x square plus 2x plus b equal to 0. So
Mhm.
then I solved it with quadratic equation. Then I
Mhm.
got so then I got equations. Then I since minus 1 and 3 are
Ah,
the
yeah.
roots, so I equated them with them. So I got two different equations: 6a plus 3b equals minus 9 and 18a plus 3b
Yeah.
equals minus 81. So when I
Yeah.
solved them, I got 6 and minus 15.
So there is no problem here. Here, see, there is no problem. We have two answers, but this answer not the. These are not the final answer. What we do is we can take the sum of the root. We can take the product of the root, and we use the formula of quadratic. And because the roots are known to me, sum is 2, and product is minus 3. Right
8 and 6.
now, the idea is a is minus 3 and b is 9, but this is not the final answer. I have to eliminate the answer using the second condition. Okay. Now the first condition is not done. We need to double differentiate also. So why we need to double differentiate? F dash x is 3x square plus 2 bx, 2x plus. Can you differentiate again? You get 6x plus 2a, right? So
Yes.
the question says that at minus 1 we have maxima. So at x equals to minus 1, the second derivative must be negative because that's called maxima. Let's substitute 6 into minus 1 plus 2a should be less than 0. So 2a should be less than 6, a should be less than 3. So a should be less than 3, and what we are getting a minus 3. Yeah, that satisfies the condition. Okay, okay. So we are sure that this is correct. And okay, this is fine. At 3, we have minimum. At x equals to 3, the second derivative is positive. So f double dash 3 is positive, which means 6 into 3 plus 2 is positive. So we are getting a is more than minus 9. So what we have b here? 9. So a is more than minus 9. So a can have any value from minus 9 to 3. This is the range of a that we are getting. So we don't know the answer, but we know the range of it. That's it. What we can say is this much only. All right. So we are having the two conditions.
Sir, what did I do wrong then in my?
Just wait. I'm not arriving at the answer. So I will arrive at the answer, then I will tell you. Then the next part is B part. It says that 4 is the local minimum and 1 is the point of inflection. Now 1 is the point of inflection. That's nice. F dash x is how much? 3x square plus 2ax plus b. And if you differentiate again, you get 6x plus 2a. And it is saying that the 1 is the point of inflection, so this must be 0. So 6x plus 2a, sorry. So this will give you 6 into 1 plus 2 into a equals to 0. So a equals to minus 3, which is correct. So we got -3 in the first case also. This is also giving me -3, and B case is also giving -3 here. So A is -3. Okay, and let's do next. The f double dash x at x equals to 4 is a minima, which means it's positive number. It's positive. So f dash 4 is 6 into 4 plus 2 into a is positive. So this gives a is more than -12. That's fine. So we got this answer. A is -3. So I think that is correct only. The A is -3 and B is 9.
So can you explain once again?
No problem. Once again,
Sir, but
first
over here, firstly, how did you get B as 9?
the product of the root is how much from quadratic equation, you know?
-3.
So -1 into 3 is -3.
Yeah.
And from the formula of quadratic, we know alpha into beta is minus b, c by a from
Yes,
the
sir.
eastern x square. Alpha into beta is c by a.
So, sir, it will be -3 is equal to B by 3. So, B will be -9.
Yeah, -9. Okay, I missed this part. Minus a missing. So I've written the same thing, but just a miss. So B is -9. Yeah, B is -9. A is -3. So if you have A equals to -3 and B equals to -9, it will be satisfied both the conditions. I think we have to find the set of points. Okay, that's fine. Just a moment.
Hello, sir.
Yes. Yeah, I think A and B are two different questions actually. Just wait. I mean, we have not one answer. We have rather. Okay. Yeah. This is the question and answer. Yes, tell me. Not to continue.
So I also got -3 and 9. So is it wrong?
Yeah, that's no, that's correct. That's correct. The answer is A equals to -3, B equals to -9. That's correct answer. And for the other part, okay, actually for each part we have answers, so it's my mistake. For first part we have answers because we got the answer from first part. Using the second part, also you have to get the answer this separately. So B part will have answer -3 and how much is that? 6 into 4.
Sir, in the first part, we didn't have to use F dash dash at all.
Yeah. Right. In the first part we got directly answer. The double dash is not required. In the second part we need it.
So can you show that?
Yes. So first part is okay, clear. This part.
Yes, sir.
So now get to the next part. In the second part, you can avoid this. So B part says that x equals to 4 is minimum and x equals to 1 is the point of inflection. So now if x is how much? X cube plus ax square plus bx plus how much? C. Come on. Now differentiate the first time. What will get 3x square plus 2ax plus b and differentiate once again. 6x plus 2a. Now at x equals to 1, the point of inflection is the second derivative is 0. And if second derivative is 0, what we can say?
Sir, what did you do?
See, here we have differentiated the
Same.
function times.
-3.
So this will give you a equals to -3, the answer. From B part, we got a equals to -3. Okay?
Yes.
Not okay. Now look at this. We have f dash x 3x square plus 2ax plus b and okay.
Sir, So we took f a double dash x is equal to 1 as 0 because 1 was the point of inflection. That's why.
Yeah, right, correct. This is the reason we have to do that. So at point of inflection, what happens? The second derivative becomes 0. So we have the second derivative, we put the x goes to 1 and we equate it to 0, we got a, which is minus 3. Now the differentiation of the first derivative is this much, and I would like to substitute the value of a which we have got, which we make it 6x plus b. And let's put this to 0. If I put this to 0, what I'll get the x value? Minus b plus or minus under root of b square minus 4ac upon 2a. So what they are saying is that at x goes to 4, you have the minima. Now minima means the second derivative is positive. At x equals to 4, second derivative is positive. Just let me see. Uh, minus 24. Relative minimum at 4. That's correct. If I differentiate. So we have to find the value of b now, which should give us a relative minimum that it does.
So for this B is coming 3.
Uh, this
So
should
can you
be
show the question?
the question is a relative minimum at 4 and point of inflection at 1.
So
So
sir, we have to put the x value as 4 and then we can find the b value, no? Because
yeah, right.
Yes, sir.
So we yes. So the b value we have to find. What we can do? Yeah. So f dash is 0. So to make this 0, how the first derivative is 0, because it's at 4 it must be 0, isn't it? This done actually. What we are doing. So for point of maxima or minima, we know that the first derivative will be 0, right, guys? Because 4 is the point of minima, it means the slope must be 0 at 4. So we can put f dash 4 equals to 0. What we get? 3 into 4 square minus 6 into 4 plus b equals to 0, which is 48 minus 24 plus b equals to 0. So b is how much?
Minus 24.
Yeah, that's the answer. Just a minute. Yeah, that's right answer. That's correct. Oh, this is done. Very easy, not at all difficult. So what we are supposed to do is at point of maxima or minima, the first derivative must be 0. That's one rule. And for what you can say, inflection, the second derivative is 0. And using this condition, you have to just solve the question. So anyway, I'll give you. I think sir will give you some tutorial for the same, and then you can practice. We'll do something more about this. This is the theory only. Now we'll do the application part in the next lecture. How to use the concept of derivative to actually solve some real world problems. Okay, so we'll solve some problem in the next lecture.
Sir, please will you
Thank
repeat the conditions at first derivative and second derivative of
you.
inflection?
Yes. Yeah. Once again, what you saying?
So no, just please will you repeat the
Yeah.
uh,
For maxima or minima local, the first derivative must be zero. That's it. For maxima or minima, I'm not saying which one. For maxima, if you want to know the maxima, the first derivative should be zero along with, and the second derivative must be negative. For minima, the first must be zero and second must be positive. For point of inflection,
Both are zero.
the first zero and yeah, and second zero. So I hope this will summarize everything.
Yes, sir.
yes sir.
So for maximum and minima, we find the first derivative zero. For maximum only, first zero and double second negative. For minima, first zero and second positive. For point of inflection, both zero, and that will be end of the test process. Okay. So we have to solve a lot of one-dimensional question, like a question in which we have just one variable and we have to apply concepts, and it's very interesting. Like we will just enjoy this process of knowing the reality of the world with the help of the calculus. Okay, so we'll see that in the next lecture. Thank you guys. Bye. Take care.
So derivative comes under coordinate geometry.
No, calculus.
Okay, sir.
Calculus. If you want to learn more, again, I will suggest buy a book by Thomas Calculus. Don't buy some Indian author. Only Thomas Calculus. The 14th edition is the best. Okay, and it's very beautifully written book. It's having lots of examples, theory, and various tricks is given, and it is like for the self learning. It means it is a really thick book, and all thick books are easiest to read from. So as the book becomes thinner, it's more and more difficult. So normally you get scared of looking at the thick book. The book is thick because it has explained everything, and if a book is really thin, you have to be worried about. Okay, so go and buy this book. I will suggest for if you're a math enthusiast, if you love mathematics, it should be in your shelf. This is something kind of a pride thing for you. Anyway, we'll see you next class.
Thank you, sir.
Okay, bye. Take care.
Bye, sir. Thank you, sir.